Hello to everyone tuning into our latest presidential collaboration video. I am joined today by current President Donald J.
Current
Trump.
and former Obama.
Why does it matter?
If they think I only did one term, that makes me less cool and powerful. But I came back and did 2 terms because I'm a winner, unlike Sleepy Joe.
Fine. Current and former President Donald Trump. And today we're going to be solving some calculus problems, courtesy of Lucy Logston.
We're going to solve them so good, better than anyone ever has. I'll introduce the first one, Barack.
Okay, Donald, take it away.
Okay, we're going to start with the easiest one. It looks like a beast, but us Americans know how to take it down with ease.
Donald, what do you mean? This looks incredibly complex. We're going to have to use the quotient rule for this one.
Oh, silly Obama.
What did you just call me?
This problem is actually quite simple. The simplest problem I've ever seen. Well, see, we're not taking a derivative, just finding the limit.
Oh, so in that case, let me just plug in e 2x minus 6. So if we plug in 3, we get e to the 0th, which equals 1. And then we subtract 1 to get 0, so the limit has to be 0.
Not so fast, Obama.
We need to stop these nicknames.
We still have to solve the bottom limit. So if we plug in 3, we get the greatest cosine value ever, which is 1. Because like a real American, cosine is able to take a 0 and turn it into something great. Turn something out of nothing and it takes a 0 and makes it a 1.
Okay, so it equals 1. So
We're not done yet, Barack. We have to multiply it by 3 to get 3, and then subtract x, which is 3, which equals 0.
But that would leave the limit indeterminable, which means the limit does not exist.
Oh, you think that, Barack?
What do you mean, Donald?
See, we can employ the greatest rule, and it's the greatest because it was made by a real American, L'Hospital's rule.
I think that's clearly the name of a French man.
Nobody but an American can come up with a rule this brilliant. See, if the limit is indeterminable, you can take the derivative of both the top and the bottom.
So we would have to use the quotient.
Hold your horses, Brocky.
Stop.
No, you just take the derivative of the top and the bottom equation separately. And then you plug in your limit value into the new equation. And that is L'Hospital's rule.
Interesting. Let me try it. So 2e to the power of 2x minus 6, which would be 2, over negative 6 sine 2x minus 6 minus 1, which would just be negative 1. So negative 2 would be the limit.
Precisely, Barack. So negative 2 is the limit of the problem.
That's ingenious, Donald. Thank you for teaching me this.
No problem, Bobna.
Ignoring that, let's move on to our next problem. Euler's method
Don't
problem.
you mean Euler's method, Barack? Like that sweet American oil?
I could have sworn it was Euler.
And once again, you're wrong. As you often are, Rocky Balbama.
That's a new one.
It's Euler. I searched it up. I had the greatest men find the truth for me. Because when I'm president, our internet is the most safe and the most trustworthy.
Okay, that's really nice, Donald. Anyway, on to the problem.
Well, we need to get to x equals 14 from x equals 4 using 2 steps. So we'll need individual steps of 5.
Wow, Donald, impressive work. How'd you know that so fast?
Well, when you're a 10 out of 10 like I am.
Alright, anyway. So next up we need to find the slope so we can write the equation. So we'll need to plug in the points 4 and negative 6 into the derivative equation. So we get negative 6 times 4 times negative 6 minus 9.
I can already tell this is going to be one ugly answer.
I know, but you'll need to trust the process, Donald.
Actually, I'm not huge on that whole process. Specifically due process.
Anyway, Donald, we multiply that all out to get 135.
And that's the slope? I don't trust you, Obama.
Euler is a weird guy. Anyway, then we write the equation. So 135 times 5 minus 6.
Hold on. Why are you multiplying it by 5? This seems stupid.
Well, when you use Euler's method, you write the tangent line, which would be 135 x minus 4 minus 6.
Mm-hmm.
And then, since we need to do one step, we'd have to plug in x equals 9, which is 5 away.
I see, but I've got my eye on you, Barack.
I'm sure you do, Donald. But that gives us 669 for the y point for x equals 9.
Great googly moogly. Never let Barack cook.
So now we plug in the point 669 into the equation for the derivative to get a slope of negative 36,135.
Barack?
I'm sure it's just a strange number, Donald.
Barack, you better not be making us look stupid.
That would be you doing that, Donald.
Fine then, I'll take it from here with your awful numbers.
Fine. Finish it off, Donald.
Alright, so now we plug our numbers into a tangent line to get the terrible equation, courtesy of Obama, of negative 36,135 x minus 9 plus 669.
Hey, I'm sure it's right.
And I'm sure it isn't. So we plug in 14 to get a multiplier of 5 to get our grand total of none other than 1,800,180. I can't even say the number. Hold on. 180,006. Any comments, Barack?
Maybe. Hold on, let me look through the book.
Silly Obama. Needing to use a book to get the right answer. Alright, let's ignore the pitiful work from that pitiful man and see.
It's right, Donald.
You're joking.
Nope.
That's stupid.
Want to take back any of your comments?
You're stupid.
Fine. Anyway, let's move on to our next problem, rotation.
Oh, don't worry, Brock. I've got this one too. I have the greatest rotating skills. I don't even need to do the math. I can just look at the problem and get the greatest answer.
Okay, then do it.
I'll show my work just to make sure you know what you're doing.
Sure.
Alright, so first let's find the top and bottom graphs. So the top one would clearly be x to the power of 3. It's strong and above the weak y equals negative 2. And then we would find the bounds of the equation, which would clearly be 0 to 2, as the equation gives that to us. So then we would create the integral for the area, which would be...
Hold on, Donald. Did you just say area?
Why, yes, I did, Barack. Glad that your ears still work in your old age.
I'm younger than you, Donald, but anyway, I'd like you to reread the problem.
Blah, 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 area enclosed, blah, 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 volume. What's wrong, Barack?
Well, Donald, like you just said, this isn't an area problem, but actually a volume problem, and specifically the washer method, due to the line that we rotated about, y equals 10, being disconnected from the area enclosed.
Well, if you're so smart, Barack, how about you figure it out?
Maybe I will, Donald. So, the first mistake...
Not a mistake, just a better way of figuring it out.
Your first mistake is that the first equation that you plug in is the one further from the line of revolution. The furthest line is y equals negative 2, and the closer line is y equals x to the third.
You're the furthest line.
Very mature, Donald. Anyway, since the line of rotation is y equals 10, you then use the setup for the washer method, which is pi r to the power of 2 minus pi r to the power of 2. And then you have to subtract the equations of each from that line that you're rotating about. So it would be 10 plus 2 to the power of 2 minus 10 minus x to the power of 3 to the power of 2. And then you would indeed take the integral from 0 to 2. And then we would have our integral that would give us our volume. But we also need to multiply it by pi to finish the equation. And then we can do this for you by plugging it into our calculator.
Well, if you're so smart, Barack, do it by hand.
You technically could, but I don't think anyone here wants to.
Touchy.
Touché. Now, when this is plugged into our calculator, we get an answer of 470.341 as our final volume.
That's one ugly number.
Yeah, well, it's what we've got, Donald.
You're used to sticking with ugly things, aren't you? I mean, just look at Michelle.
Shut up, Donald. So that is how you find the volume of the solid over the rotation.
I could have done it.
I'm sure you could have, Donald.
I could have.
No, you would have just signed an executive order banning all calculus problems. Donald, no.
I am uncapping my pen.
Donald, I was joking.
What good does calculus really do for us, Barack?
Well, actually, it helps with many complicated topics, such as rocket science.
No, it does nothing good. It just takes away time that real American patriots could be using on more real American activities.
Like what?
Golf.
And?
War.
Donald?
I'm gonna sign it.
Donald, no.
I'm doing it.
Donald,
no.
Stop signing the order right now.
Calculus.
Whoa, Donald.
See, Barack? Everything's perfect.
I never thought I'd say this, but you're right, Donald.
Finally, we have world peace.
And all because you got rid of calculus.
I've been very long ago.
Sorry, guys. Jill was yelling at me again for spending all of our third, fourth, fifth honeymoon money on more ice cream. But I'm ready for the calculus video, guys.